Vectors support fast insertion and removal of elements at the end of the sequence. It turns out it is possible to insert elements at any point in a vector, but the library deliberately doesn't make this convenient. So we saw in a previous video that the std_list type supports an operation called push front, an easy way of adding one element at the beginning of the sequence. Whereas in a vector, there is no push front, but there is push back because adding elements at the end is fast. So that's a way for the language to hint at you that if you want to add stuff at the beginning, maybe try using a list and not a vector. But there is still a general function provided to insert elements at arbitrary locations in the sequence collections like vector and list. It's this .insert function. And the syntax for .insert is actually the same for vectors and lists. But then the question is, wait, if I want to insert an element at an arbitrary location, how do I indicate what location I want? Well, I mean, for a vector, I could say something like, if I index this, hey, insert something before index 2. But as I just said, the insert function has the same syntax for vectors and lists. So I can't use indices on lists. That doesn't make any sense. So I have to find some general representation of a position in my collection. And as we saw in the previous video, that is an iterator. And so the insert function, which allows us to insert elements at arbitrary locations in our vector, requires us to know about iterators. These days in CSC 116, this is one of the only reasons we care that much about iterators. We're not going to see too many uses for iterators. They are important and useful, but their use cases are relatively limited because of all the other convenient things the language now supports. So I want to go over how to use .insert to add elements at arbitrary locations in vectors, and the same syntax will also work for lists. I also want to talk about deleting elements from arbitrary locations. So the first question is, can we insert an element at the beginning of the sequence? So in this context, before the number 6. The syntax of .insert expects you to provide an iterator and a position and an element to insert. And the element gets inserted before whatever position the iterator points to. So if I want to insert something here, then what I need to do is get an iterator to the element that would appear right after my new element. In other words, I want an iterator pointing to this. So I guess I could conceptually, like, here's my variable iter. So I'm going to create an iterator pointing at the 6, but of course I'll observe that currently the 6 actually is the first element of the sequence. So iter equals v.begin. Again, like in the last video, I'm using the auto keyword to represent the type of my iterator, and I don't bother writing the type on here, but I guess I could point out what that actually is. The real type of an iterator is this. So I go into the standard library, std::, I grab the type vector, I go inside of that and grab the type iterator. And the reason why this is significant is the type of an iterator does depend a lot on what you're iterating over. An iterator over a vector does do something different than an iterator over a list. Not to you. To the user of the iterator, all iterators work the same way. But internally, the iterator over a vector has to do something different. Similarly, because the elements that you're working with the iterator might have different types, the type of the iterator also depends to some extent on the element type of the vector. So the real type of the iterator is actually this. And this is a bit too many colons for my taste, so I'm going to use auto. And that's one great development of modern C++ is the auto keyword for reasons like this. Although it was nice earlier to use the auto keyword as a clever way of not remembering to write int or float, the real applications of the auto keyword begin showing up when we work with very long types, like the types of iterators. So I get an iterator pointing at the beginning of my sequence. And now I call v.insert, and I give it the iterator as the first argument and the element as the second one. So I insert before the position referred to by this iterator, I insert the value 100. And that should give me something like this. If I try running that, so I first print out the initial vector, and then I print it out after inserting 0 at the beginning. We can see, yep, sure enough, 100 has been inserted at the beginning. Sorry, I'm inserting 100. I now want to insert 0 at the end, and that has not been done yet. So I've got a couple of ways of doing that. First, I could use pushback. And frankly, on an exam or something, that's what you should do. By now, I think you're used to using pushback. But I want to talk about this with dot insert just to answer a sort of conceptual question. I don't want to leave you hanging in a conceptual sense here. So if I want to insert an element at an arbitrary position, what I do is get an iterator pointing at the next element, and then I call dot insert. So if I want to insert something before the number 10, I would get an iterator pointing to the 10, and then I would call dot insert, and I would insert an element here. But then the question is, hey, wait, if dot insert can insert literally anywhere, how do I get dot insert to insert at the very end? Because I need dot insert to take as its argument an iterator pointing at the next element. And the answer is, well, wait, there is no next element here because it's at the end. But remember that after every standard collection, after the sequence, there is this imaginary invalid element referred to by the iterator v.end. So if I want to insert at the very end of the vector with dot insert, I could use v.insert, and then I insert before v.end, and I'll insert the value 0. So this is equivalent to push back. And this up here is sort of the vector equivalent of push front, although vectors don't actually provide push front. And there it is. So we can see we now have 0 at the end of our sequence. Okay, and then finally, I want to insert somewhere in the middle. So task number 3 is, first, I would like to get an iterator to the position of the third element, so what is currently index 2 of my vector. I guess I should redraw the vector to reflect the elements I've added. So there's the 0. What I would like is to insert the element 187 before the current contents of index 2. So this is index 2 here. So I need to get an iterator pointing at this element, at the element at index 2. So I'm going to just I'll draw that in, and then I'll work out how to make that happen. So the way I'm going to do this is I'm going to create a fresh iterator with v.begin, and for reasons that'll come up in a future video, once you modify a sequence, like dot insert or dot erase, it's often better to be a bit neurotic and give up on any iterators you already have. There are complicated rules for this, but basically, if I have iterators pointing into a sequence and I modify the sequence, those iterators may become invalid and I may not be allowed to use them again. So that's one reason why it might be better, at least at first, to take a position that iterators are sort of disposable. You create an iterator, use it for whatever you're going to use it for, and then throw it away and get a new one if you need to iterate again. So in task 3, I'm going to do that. I'm going to say iter, I'm going to use the same variable iter, but I'm going to start it again at the beginning. And I want to position it at element number 2, or element at index 2. So it starts positioned at the 100, and so I'm going to do plus plus twice to get it to index 2. So iter plus plus, iter plus plus. And then I'm going to insert the element 187. So v.insert, before the position referred to by iter, I want to insert the value 187. And then we'll try that out. And there it is. I inserted the value 187 before index 2, so I spliced it in here. Now, as I mentioned in a previous video, although this is doing the insertion for me, the vector is doing the insertion, remember that inserting elements in the middle or at the beginning of a vector does require shuffling everything around. So although dot insert, sort of is taking care of that accounting for me, it is still happening. When I do this dot insert operation, the vector is having to move a lot of things around internally. If I find that I want to do a lot of splicing in of elements, I probably should use a list instead. But we're still one video away from expanding a bit more on the uses of lists and sets until we've seen more about iterators. All right, so the next thing I want to talk about is the dot erase function. So I have this sequence now that I've inserted a bunch of stuff into. Let's just clean that up a bit. So it currently looks like this. Okay, so I've got, 7 elements in total. What I want to do now is talk about, now that I've inserted a bunch of stuff, I want to talk about how I can delete it. And there is a function .erase defined for vectors and lists and other standard collections that allows me to delete elements from wherever they appear. But first I have to find them. So .erase uses an iterator. And one reason for this is, how else would I tell the vector what element I want to delete? If I just say delete the number 6, then what happens, for example, if the number 6, if the number 6 appears in the vector more than once? How many times do I delete it? So instead, to be precise, I have to tell the vector what position do I want to delete today. So to do that, of course, I use this abstraction for what a position of a collection is, which is an iterator. So I'm going to create an iterator, and I'm going to position it at index number 1. And then I'm going to call .erase. So I'll start at the beginning, so v.begin. I do iter plus plus to advance the iterator to point at position 1. There it is. And then I'm going to call v.erase to delete the element at that position. And we'll try that out. I'll forget to put a semicolon and put a colon instead, so we'll fix that. and then we'll try running it. And we can see here after I do the dot erase, so I get an iterator positioned at this second element at index 1, which is the number 6. I tell the vector, please delete that position. The vector conceptually does this. So the abstraction of the vector being a sequence results in this vector here, where it goes 100, then 187, as we can see down here. However, keep in mind, internally, the vector had to shuffle a whole bunch of stuff around to get that operation done, which is fine. I mean, it took care of it for us, but that might be slow. If I want to do this a lot, I might want to use a list instead. But what's nice is, now that I have this abstraction of an iterator as a way of holding my place in a sequence, I can use the same functions in a list as I would on a vector. It's true that holding my place in a list is different than holding my place in a vector, but with the abstraction of an iterator, I don't need to worry about the difference. I leave that to the iterator and the vector, or the list, or whatever collection I'm working on, to handle for me. Okay, so now we've seen how we can use a vector to insert elements or erase elements anywhere we want. But of course, we've also seen earlier that if we want to do that a lot, we might use a list. And again, it's now going to be about choosing the best data structure for the set of operations that I need for a given application.